Welcome to the presentation about self-descriptions. My name is Anja Strunk and I'm a member of the self-description group, and I want to show you today an update about the work we did within the last weeks regarding self-descriptions. What do we want to do today? First of all, I will give you a short introductions, why we need self-descriptions and why they are important within Gaia-X. The second part will be about important definitions you need to know and to understand in order to write and use self-descriptions. The third part will be for users. That means for those of you who want to write self-description, and I will show you the tools and the tutorials we have so far. The fourth part is for developers. That means for those of you who want to contribute to the development of self-descriptions, and I will show you the governance process and the single point of truth. And the final fifth step is regarding the next step. That means I will show you an outlook about the work we will do within the next weeks. Let's start with the introduction. Within the Gaia-X world, we have several entities who want to interact with each other. For example, we have a consumer on the one side and we have the provider on the other side. The consumer defines the requirements he has regarding a service. For example, the consumer is saying, I'm looking for a sustainable text-to-speech converter service hosted in Germany. The provider on the other side defines the service he's offering. In our case, he says, I have a green text-to-speech converter service hosted in Frankfurt. A human being may think or may map both statements, this of the consumer and this from the provider, to each other, and will recognize, okay, the service the provider is offering is the same as the service consumer is looking for, because he knows, because of his context information, that Frankfurt is hosted in Germany, so this requirement is fulfilled, and that green is a synonym for sustainable, so that this requirement is also fulfilled. So a human being can, but a machine cannot. And that's where the self-description come into play. The self-description describes a common controlled vocabulary to describe the entities in the Gaia-X universe. So they define the terms and the vocabulary a consumer can use to describe his requirements and a service provider can use to define his service offering. And I said that the self-description are required to describe all the entities within the Gaia-X universe, and in our case means that we have 4 self-descriptions. We have the self-description of the consumer, which contains especially an ID to identify the consumer so that the provider knows with whom he is interacting. The vocabulary is also used to define the requirements a consumer has. It's used to define the service, to describe the service of the provider, so to describe that sentence, and also to describe the provider itself, which is, for example, an ID, which is the name, a legal contract, a web address, a physical address somewhere in Europe or the globe. So a lot of attributes to describe that provider in more detail, and especially every attribute both parties, the consumer as well as the provider, needs to have a commercial interaction. Let's dive into the scopes and the definition of self-description. Self-description, the term self-description is used synonymously for 3 artifacts within Gaia-X. We have the claims of the one side, we have the verifiable credentials, and we have the verifiable presentation. The claims are just statements about an entity, for example, about a service. My service is green, or a service which is hosted in Frankfurt, or that the provider has an ISO certificate. There are just claims. There is no proof, no guarantee that these statements are true. This is something which is done by the verifiable credentials. So a claim will be a verifiable credential if there is a trustworthy entity who checks if a claim is true and puts a stamp and the signature on it. This is a difference between a claim, no check, no signature, no trust, and the verifiable credentials where is a check, a signature, and a stamp on it. And the verifiable presentation is just a subset of all verifiable credentials an entity has. For example, if I'm a provider and I have these three credentials, then I can decide by myself whom I show what credential. And this verifiable presentation, for example, is just one verifiable credential, which is my services screen. These three artifacts are developed within different groups in Gaia-X. We have the service characteristic group, which is responsible for defining the vocabulary for claims. Again, a claim is just a statement. There is no check, there is no guarantee, there is no chain of trust, there is nothing at all. All the signature, check, and chain of trust is done within the self-description lifecycle, which is responsible for defining models, techniques, and processes to check claims, to sign claims, and to also guarantee and verify the chain of trust. In my presentation, I will focus on the claims. This is the part the group service characteristic has. I will focus on the claims and on the vocabulary to define that claims. I will not go into detail regarding verifiable credentials and verifiable presentations and what you need to do to sign a claim and to build a chain of trust. This is out of scope of that presentation. I just want to show you the vocabulary for the claims. Another very important definition you need to know is the conceptual model. Here on the right side you have the conceptual model. The conceptual model is defined within the technical architecture document, which is released quarterly. The last one, or the latest, is in from December last year. And this conceptual model defines all entities which are existing in the Gaia-X universe. For example, here, which is just a part of the conceptual model, we have, for example, a resource owner, we have a resource, we have a service instance, we have a provider, and so on. And the conceptual model, although defines which entities, that means which classes you can see here in the conceptual model, needs a self-description. And these are the classes which have a blue background. So you can say the conceptual model explains what have to be described, whereas the self-description schema defines how such a class can be described. So it's mainly very, very simplified, a collection of mandatory and non-mandatory attributes which are available to describe an instance of a provider, a consumer, a federator, and so on. And the self-description schema also defines the constraints to use such vocabulary. For example, a provider can have several attributes. It can have a physical address, it can have a sales number, a text number, it can have a legal person, it can have, for example, a registration number, and so on. The constraints will tell you which attributes have to be there and how often. For example, there must be exactly one sales number or exactly one registration number. There must be one legally binding name. But maybe there are several physical addresses because the provider has different quarters, different locations around the globe. So the conceptual model defines what has to be described. The self-description schema defines how an entity can be described. So far to the definition. Now I want to dive into the tools and the tutorials we have for the users. We have defined a tool chain, which consists of 4 parts currently. we have the creation wizard and the Java library to create self-descriptions. And when you have that file, you have a validation wizard and a visualization tool. The creation wizard is just a web formula-based UI tool which helps you to create self-descriptions. The tool is already online and I can show you how it works. Here we have our creation wizard. You have to do 4 steps to create a self-description. I will show it for you. First of all, you have to upload a shackle shape. The shackle shape defines all the attributes which are available for an entity. You select it, you upload it, and here we have 3 entities we can describe: provider, participant, and measure. We choose provider, and here the creation wizard shows you a formula-based web page where you are requested to type the information for all the necessary attributes, and every attribute which have an asterisk at the end is a mandatory attribute. You have to type something in, otherwise you cannot save the self-description file. And we can do it. As an example, has legal form is GmbH, has web address is www. We have the acme company, acme.com. Legal registration number 01234567. We have a legal binding address, which is Foo Street 42 in Bar City, Germany. The jurisdiction is also Germany. We have a sales tax number. The company is located in Germany, so we have a German sales number. And the legal binding name is Acme GmbH. We have filled in all the required attributes. We click on Save, and you get the JSON LD representation of the self-description we typed in previously. You can now save it or publish it where you want to. So far to the creation wizard. When you have that self-description, you can input it in the validation wizard, and the validation wizard gives you a feedback if your self-description is syntactically correct. For sure, if it's the output of the creation wizard, it will be, but you can also type it by hand if you want to. You have to know that the validation wizard just checks the syntactically correctness, and you get a green arrow, a green mark or a red mark if it's not the case. So that's just the syntactically correctness. There's no checking of signatures. There's no check if a claim is true, somebody made. There's no chain of trust, nothing at all. It's just syntactically correctness. You can also take the self-description and put it into a visualization tool. And the visualization tool is a hierarchically visualization of the self-description, normally with some dots and with association between them, and you can click through it and navigate through the self-description, also to self-description which are references. It could be, for example, self-description of a provider, and the provider self-description reference also service offering he's doing. So it's a nice way to look at self-descriptions. The second way to create self-description besides the creation wizard is a Java library. And it's just a set of classes which allow you to create and manage self-description within Java. The Java library is not yet finished. The validation wizard will be in calendar weeks. We also have a lot of tutorials, or we will have a lot of tutorials, and also self-description templates. You have a look in it. I will show it to you. When you go to our self-description Git repository, you have a landing page where the Git is explained and where also some links to important information As they are, for example, you can click here on the self-description tutorial and you will have some information about how to write self-description. It's not yet ready, it's just a skeleton, so we will improve the documentation in the next weeks. And you also have a folder with a lot of samples. When you go to implementations and to instances, you have the different classes. When you remember, we have different classes according to our conceptual model. And for that classes, you have here samples. For example, the Acme provider, which is from the hackathon. You have here a JSON LD representation of the self-description of the Acme company, which we all know from the hackathon number 2. That's all regarding the toolchain. We know the toolchain is not yet ready, but we are working on it to get the first version of all that tools up and running so that you can use them and play around with self-descriptions. How about developers? If you want to contribute to the development of self-description, what do you want to do? To support the definition of self-description in a formal manner, we have defined a governance process. And the single point of truth are YAML files. What does this mean? You know that we have a conceptual model from the technical architecture document, which defines all the classes which needs a self-description. And we have also a conceptual model in our repository, which is a copy and also an extension. So maybe the conceptual model in the architecture document is not precise enough, for example, to model bare metal service offerings or virtual infrastructure as a service offerings and that stuff. That means we will extend the conceptual model in our repository and we will sync between those two conceptual models manually. And out of that conceptual model, YAML files are generated. The YAML files contains all the attributes which are available to describe a specific class. We have, for example, a YAML file for provider, we have a YAML file for participant, and so on. I can show you this in our Git repository. When you go back, you have a folder called YAML, and in that you have a lot of files for each class in the conceptual model. You have one. When we go, for example, in the provider YAML, you have here in a YAML format the definition of all the attributes we have so far. This is exactly the attributes we typed in here, just to let you know. We have here the legal form, we have a data type, we have a cardinality, how much or how often that attribute has to be set. We have a description, we have example values and all that stuff. So we have a single point of truth where all the attributes or the vocabulary which are available to describe a specific class, a specific instance are stored. And out of that YAML files, the SD schema is created. And also the documentation for that schema is created. This is everything done automatically. And also our tool support for the users are created in a way that they are not programmed, that all these formula are created or implemented by hand. This is not the case. So these tools take the SD schema as input. This is what I done previously. When I started the creation wizard, I had to upload a shackle shape file, and this is exactly what it's visualized here. You input the self-description schema into set tools, and you can use them immediately. So what does this mean when you want to contribute to the development of self-description, when you want to change attributes, when you want to add new attributes? You have to do two steps. You have to extend the conceptual model, which is this here. And you have to extend the YAML files with the mandatory and non-mandatory attributes. These two steps you have to do in order to contribute to the development of self-descriptions. So far regarding the governance process and the single point of truth. Let's dive into the next steps. So what we want to do in the next weeks is to define the self-description schemas for different service types, for infrastructure as a service, which is mainly virtual machines and bare metal. For data as a service and also for Kubernetes as a service, we will extend or refine the conceptual model and define the attributes which are available to describe the three different service types. We want to publishing all our tools, and we also want to fully implement the DCI pipeline. This means if you do a change in the YAML files, that the ontology, the SD schema, the documentation, and all that stuff is generated automatically, so that the tools and the documentation is always up to date. How does such, when we go back to the providing the vocabulary for the different service types, what does it mean? I told you that this means extension of the conceptual model. And here we have an example for the extension of the service offering. We have the service offering class coming from the conceptual model, and we find it in several other service classes, for example, software as a service, where data as a service is a subtype, platform as a service, where Kubernetes as a service is a subtype, infrastructure as a service, where bare metal as a service is a subtype. The same is doing with a resource. You know that every service offering is a composition or maybe a composition of other service offering and resources. And resources can be data, software, node, and interconnection. And we will define each of these class if necessary in more detail. For example, we did it for a node, which can be a container, bare metal, or a virtual machine. And we also define the associations and the links between all these classes. And the final step is to define how a special service offering class is composed by resources. This means, for example, for the data as a service, that the data as a service has at least one resource called data associated with it. Otherwise, it's not data as a service. And the bare metal as a service has to have at least one bare metal node and also an interconnection of this bare metal node with the outside world so that you can use it. So this is what we have to do in the next week. We have to define for each service class the extension of the service offering, the extension of the resource, and also to define the service composition, how each service class is composed by which resource or other service offering. That's all from my side. You are welcome to contribute to the self-description with new attributes, give feedback to the work we're currently doing. You are welcome to do it. You can also use the tools we have so far, play around and give us feedback to improve Gaia-X and also especially the self-description further.